Assalamualaikum and good day. My name Muhammad Hizairul bin Zakaria. This time our group will discuss about water quality monitoring at Setia Ecohill construction site. Setia Ecohill is a 1010 acres township development located on lot 39 Mukin Beranang, District Hulu Langat, Selangor Darul Ehsan. This township construction site have few water outlet to nearby river. So water quality monitoring was conducted to ensure water quality discharge from construction site is not polluting due to the construction activity. Few topic we will discuss in this video, which is first, the potential pollutant and risk. Second, monitoring methods. Third, finding result, and lastly, mitigation measure and best practice.
Assalamualaikum, my name is Sahir Azam Miramli. I will present the third potential pollutant and risk at our site project. Potential pollutant that could be discharged into the river from the construction is very depending on the nature of the construction activities. Here I list 5 potential pollutants from the construction site. First, sediment. One of the most prevalent pollutants from the construction is sediment. Soil erosion caused by the land disturbed during construction can result in sediment runoff into the nearby water body. Sedimentation can cool, reducing the penetration necessary for aquatic plant growth. Something aquatic habitat and altering stream bed morphology, which they affect fish spawning ground and aquatic insect habitat. Second, construction debris. This include materials such as concrete, asphalt, wood, and metals. Debris can basically disrupt aquatic habitat, water flow, create the barrier for the fish migration. It can also introduce harmful chemical into the water as they break down. Third, chemicals. Construction activity involve the use of various chemicals, including paint, solvent, and sealants. Improper storage, use, or disposal of these chemicals can lead to the spill of the runoff into nearby water bodies, contaminating the water and posing the risk to aquatic life and human health. Chemical pollutant can disrupt the balance of aquatic ecosystem, harm fish and other aquatic organisms, and affect water quality. Fourth, oil and grease. Machinery and equipment used in the construction may leak oil and grease, which can accumulate on the surface and be washed into the water body during rainfall. Oil and grease pollution can create slick on the water surface, impair oxygen exchange, and harm aquatic organisms through the toxicity and habitat degradation. And fifth, heavy metals. Construction activities can release heavy metals such as lead, mercury, cadmium, and zinc into the waterway through the runoff from the exposed soil or leaching from construction materials. These metals are highly toxic to the aquatic life, causing various adverse effects such as developmental abnormalities, reduced reproduction rates, and impaired growth. The risk posed by the pollution to aquatic ecosystem, water quality, and downstream community are significant. First, ecological impacts. Pollutant can disrupt the balance of aquatic ecosystem by harm fish, amphibians, macroinvertebrates, and other aquatic organisms. This can lead to the decline in biodiversity, change in species composition, and disruption in food webs. Second, water quality degradation. Pollution can degrade water quality by increasing turbidity, nutrient levels, and concentration of harmful substances. This can impair water availability for drinking, recreation, and agriculture, leading to the economic, users, and public health risks. Next, I will pass to my friends. Thank you.
Assalamualaikum dan salam sejahtera. My name is Wan Razali. Now I will present the monitoring protocol or method. 1. Site survey. Possible sources of contamination and physical characteristics of the water at the point of sampling were observed. 2. Sampling point. 10 sampling points were selected for water quality monitoring as follows. Number 1, the location point W1 near Kampung Sesapan Klubi. The water condition observed slightly turbid. Point W3 near cattle and vegetable farm, slightly turbid. Point W4 within oil palm, rubber estate, slightly turbid. Point W5 near Kampung Kembu Hile, slightly turbid. Point W6 near cattle and goat farm, slightly turbid. Point W7 near Kampung Rincing Hulu, the water condition observed slightly turbid. Point SB12A sediment basin, turbid. Point SB18 sediment basin, slightly turbid. Point SB22 sediment basin, slightly turbid. 3. Collection of sample. Water sample were collected from 9 of the 10 select point. Grab sample were collected and preserved in an ice box prior to being transported back to the laboratory for chemical analysis. The sampling was carried out for 1 day, and during sampling, the weather was fine. For analysis, on-site testing of the pH, temperature, and dissolved oxygen were conducted. Water sample were brought back to the laboratory for analysis. The parameter of analysis: 1. pH value, 2. temperature, 3. dissolved oxygen, 4. chemical oxygen demand (COD), 5. biochemical oxygen demand (BOD5), 6. total suspended solid, 7. oil and grease, 8. ammoniacal nitrogen (NH3), and 9. E. coli count, 10. turbidity. Method reference: APA mean standard method for examination of water and wastewater, 21st edition, 2005, American Our and Water Environment Federation, WEF. So, thank you.
Hi, my name is Raizat Zulkapri, and today I will present the result of water quality monitoring that was conducted at the river outlet discharge from the site. Okay, so first of all, I will share the data analysis result of water quality monitoring for the purpose project mixed housing and commercial development on lot 39 Mukim Branang, district of Hulu Langat, Selangor Darul Ehsan. From W1 to W4, based on table 1, the result show that 7 parameter test was taken and it was in range class 2A. For example, from the table, for dissolved oxygen at W1 is 6.4 mg per liter, COD is 6 mg per liter, BOD is 1 mg per liter, pH is 6.4, total suspended solid is 28 mg per liter, and ammoniacal nitrogen is 0.08 mg per liter. Next, we also look on table 2 that we can see the W5 to W7 point is also in class 2A based on National Water Quality Standard for measure. Next is Table 3, Analysis Result of Water Quality. That was conducted at retention pond. From that, we have taken 3 points only: SB 11A, SB 18, and SB 22. From that, only 4 parameter tests was taken. The first one is pH, the second dissolved oxygen, third one is total suspended solid, and the last one is turbidity. So from that we can get the National Water Quality Standard is class 2A because, for example, the SB18, the pH is 6.6 and the dissolved oxygen is 6.2, total suspended solid is 20, and turbidity is 24. Okay, from the table data analysis result, we can conclude that the water discharge at the river from the site there was in class 2A and there are need to conventional treatment required. So for the next slide or video will present by Mr. Sharul on mitigation measure. That's all from me. Thank you.
Assalamualaikum. My name is Sharul Aidil bin Ismail. I will explain about mitigation measure and best practice. Implementation effective mitigation measure and best practice is crucial for minimizing impact on water quality from construction site. Here are some commonly employed strategies. First is erosion and sediment control. Erosion and sediment control are critical aspects of land management, particularly in construction, agriculture, and land development projects. They involve strategy and measure implemented to prevent soil erosion and the movement of sediment, which can lead to environmental degradation, water pollution, and loss of fertile soil. Methods related to erosion and sediment control such as seep fence, erosion control, blanket, and sediment basin to prevent soil erosion and sediment runoff into nearby water bodies. Next is stormwater management. Stormwater management refers to the process of controlling rainfall runoff to minimize its negative impact on the environment and infrastructure. When precipitation fall on impermeable surface like road, parking lot, and rooftop, it can infiltrate into the ground naturally. Instead, it flow over this surface, picking up polluted like oil, chemical, and debris, and eventually enter waterway, causing pollution and erosion. Effective stormwater management aim to mitigate this issue by implementing various strategies and techniques, including first a retention and detention basin. These are engineered structures designed to temporarily hold stormwater, allowing it to slowly infiltrate into the ground or be released at a controlled rate. They help reduce flooding downstream and promote groundwater recharge. And next is green infrastructure. This includes practice such as permeable pavement, green roof, rain garden, and vegetated swale. This feature help to absorb and treat stormwater, reducing runoff and filtering polluted before they reach water bodies. And last is construction entries and exit control. Establish and stabilize construction entries or exit with gravel or matting to prevent tracking of sediment on onto public road, thereby minimize runoff into water bodies. Okay, by implementing this mitigation measure and best practice, construction site can minimize their impact on water quality and help protect aquatic ecosystem. Okay, that's all from me. Thank you.